Okay, Maddie, I almost forgot you. There we go. 88. Okay, instantaneous rate of change is when we're going to find f prime of x. Okay, so we were provided f of x. Instantaneous rate of change is the derivative. Okay, we start talking derivative. So if we do this derivative, I didn't write the original function, but you have it in front of you, yes? So when we do the derivative, 4 times 1 4, what do we have? X to the third minus derivative of 2/3 x to the third is going to be 2x squared. Derivative of 1/2 x squared is x minus the derivative of 1/2 x is 1/2. And I guess I'm realizing, in case Maddie is looking at this, here is the original function. Okay, so instantaneous rate of change is that. Okay, we found that. That's all we can do with that right now. The question is, when does that equal the average rate of change? So both of these, this is your, Ethan, you threw this in yesterday, IROC versus AROC. Remember? I kind of forgot about those vocabulary pieces, but we use that, right? So we want to know when they are equal. In order to do AROC, the average rate of change, we are looking at our interval, which the provided interval is 0, 1.565. And so if you think of these as your A and B values, essentially to do our average rate of change, f of B minus f of A over B minus A. So in this case, we're going to do f of 1.565 minus f of 0. That was weird. There we go. Over 1.565 minus 0. And essentially it's asking when are these two equal. Now, this is a calculator problem, yes? Yes, because it's 88. So we're in the calculators. Since we're in the calculators, I would not do this by hand at all. Okay? And in fact, my suggestion is that when you do this, first of all, what I would do is I would go ahead and go to my y equals screen, and I would type in what f of x is, because if I type it in once, I'm done. So I'm going to type in 1/4 x to the 4th minus 2/3 x to the 3rd plus 1/2 x squared minus 1/2 x, correct? Here's the deal. That's my y equals. I don't have to graph that. I don't have to do anything with that, but that's my y equals. And here's what I can do. Because when I go back to my regular calculator screen, I'm going to set up a fraction. F of 1.565. Well, where did I just plug f in? That is my y1, yes? So I could go here. I know it's somewhere else also, but I like to use my alpha menu. Alpha F4? Yeah. Alpha F4, notice it pops up y1. So I can hit y1 and then use, just like you would f of a number, use parentheses. So y1 of 1.565 in parentheses minus y1 again, because now it's y1 evaluated at 0 over 1.565 minus 0. That just did all the work right there. Now, do you have to do it that way? No. Okay. I'm just, definitely makes a lot more sense than trying to type in 1.565 every time, in my opinion. So, now we have negative 0.3920573854, that big long thing, yes? And so now the question is, When do those two equal each other, right? And actually it says for how many values. It doesn't say when or where. For how many values of x in this interval are those two equal? Well, how can I figure out when they're equal? I mean, we could set up an equation that is x cubed minus 2x squared plus x minus 1/2. But that's going to be ugly numbers. And it's not like it's a quadratic or something that we can use quadratic formula. That's going to be a cubic, which our best bet to solving a cubic is to factor. I'm not going to be able to factor with this mess when I move it over. So you need to graph. In order to find out when these two are equal, graph each piece and look for when they meet up. Okay? So if I go back to my y equals, now, y1 was the original function, right? Is that what I need? No. So I don't want to get rid of it yet. I'm just going to turn the graph off. You remember how you can turn a graph off? On the equal sign. But in y2, x to the third minus 2x squared plus x minus 1/2. And I want to know when it equals that piece on the front. I'm curious here. I don't think this is going to, nope, that's not going to work because it's going to, okay, so I'm just trying, there's got to be a way. I just have to, I'm not very graceful with it. If I go back to my main screen, you see this value here? I don't know how often you guys have used memory on a calculator, but over at the bottom left, I have store and recall. I'll be honest, I don't use these very often myself, so I'm going to be a little rough here. But over here is store, yes? I believe if I hit store right now, I have to store it to something, don't I? How do I do this? I got to remember. What am I going to store it to? Anyone know my answer to my questions? I don't. I know there's a way to, where do I store it? Okay, well, I don't know if that'll work or not. I just stored it to X. I'm not sure that's going to do the right thing. But I'm all about trying here. It did not. I know there's a way to get it there, to store it somewhere. I just don't know what it is. What if I do a store? Oops. What if I store it here to like UVW, something like that? I'm going to store it to U. Nope. I don't remember how to store it, guys. Sorry. There's a way. Yeah, I don't remember. So at this point, what I'm going to do is I'm going to type in, because I'm wasting time here. I'm going to type in that number the best I can. Since I'm not coming up with, unless. Nope, didn't like that either. I'm trying things. Okay. So I'm going to type in negative 0.39205. Whoa, what did I do? Negative 0.39205. 73854. That's going to bug me. I can't remember a better way to do that. Okay. There's a line there, yes? It's very close to the x-axis, yes? As it should be. I'm just going to do a basic zoom in, because if I think I zoom in, I'll be able to see what I need to see. There's the cubic. There's the line, yes? We actually just need to know how many times, didn't we? So could we zoom in again? Or actually, you know what? About some Z-box action. Although I have a pretty good idea of how many times. Do you guys?
I do.
So if you need confirmation, don't forget Z-box. Trace times. And for how many values of x in the open interval is the instantaneous equal to the average on this interval? And so, oh, this is multiple choice, wasn't it? So this is the answer of 3. 3 times, if you will. Okay? This is the way we should be able to take that answer, but I'm not figuring it out, so. Yes?
Can you do this one on the board for B?
For B?
Yeah.
You guys got what you need from this screen, right? So, pre-response, 4B is where I'm at. So that's going to be in your second set. And it wants, this is going to be awkward because we haven't done A, but I can go back and do A later if someone wants it. But find the absolute minimum value of G on this interval -4 to 4. Justify your answer. Okay, how do we, just think in general, how do I find minimums? Okay, when the slope is 0, so when the derivative is 0, yes? Okay, so we need to find, this is a minimum value of G, so we need to find G prime. Okay, in order to find G prime, let's go back and see, and this is where you go back, you always go back to the original stem. Okay, when you hit these other pieces, you're going to go back to the original stem. What do we know about G? G is -4 to x, the integral. So there's G, yes? We need to find the derivative of that and set it equal to 0. Make sense? Now, the derivative here, in order to do G prime of x, we're doing the derivative. So this indicates derivative, the derivative with respect to x from -4 to x of f of, t dt. Well, what do you remember? Derivative of an integral, essentially, cancel each other out. You take, this is a variable or variable expression when we do this, and you're going to take this and plug it in here for t. So the derivative of the integral is just going to end up being equal to whatever f of x is.
In this case, is it going to be different in other things? Or is it always just going to be the original?
Well, the only difference would be like if this was something other than x, like if say this was x squared, then it'd be equal to f of x squared. In other words, you have to plug in, if this is something other than just a plain old x, if it's a sine x, then you would plug that in right there.
If it was a number, is it the same?
I don't know that you would just see a number in this scenario. I've struggled with that. I don't feel like you'd see a number.
Okay.
Because this is part of our fundamental theorem of calculus here. Okay? So, we are looking for minimum values, right? So we're looking for when these pieces are essentially equal to 0. Well, our critical points are going to be when these are equal to 0. And we were on the interval -4 to 4. Okay, so if you look at this, I don't have my work. I never showed the work of how I found those other pieces, did I? Bless you. So, only thing I can think of, oh, it would just be, okay. So, okay guys, in order to find critical points, we're setting our derivative equal to 0, yes? Well, what do we have? G prime of x equal to 0, but G prime of x is equal to f of x. What do we have for f? F is the graph. So when does your graph equal 0? By way of the graph, my graph equals 0 at -4, -1, 0, 1, and 4, correct? Yeah. Those are the places my graph crosses the x-axis.
So you don't set f of x equal to 0?
F of x is the graph. Are you looking at that function there?
Yeah, I did the function and set equal to 0.
Okay, but that function is only defined for 1 to 4. That f of x function is only for 1 to 4. We talked about this morning, so it's fresh in my head. Okay, so it's not.
Oh yeah.
That would give you these two.
Yeah,
but then you're missing out on the others.
Okay.
Does that make sense?
Yeah.
Okay, it's the catch, you know. There's a lot that they define in these. Now, two different things that we can do this way. Officially, if we are looking for the absolute minimum, you could just make your XY chart and do your candidates test right here. That's not what I did on my answer key, when you look at my answer key, right? But one option is you could just go ahead and do your candidates test. -4, -1, 0, 1, 4. And these are minimum values of g of x, right? So I guess where I said y here, I really need you guys to think g of x, which g of x is going back into this interval. So you're doing the area under the curves, which we do that in the previous, we already have a lot of those areas from the previous part, don't we? Okay. The other option is I also looked at a number line, so I didn't have to do all of these. -4, -1, 0, 1, and 4. And I looked at, okay, when are things positive or negative? Okay, when is your derivative positive or negative? Which, when we talk about our derivative being positive or negative, well, g prime is what? It's f, which is the graph. And so what do we know? From -4 to -1 on the graph is positive. From -1 to 0, it's negative. 0 to 1, it's positive, and 1 to 4, it's positive, yes? Positive derivatives indicate what? Increasing pieces of the graph. Negative derivatives indicate decreasing portions, okay? And so then, where could mins occur? Mins could occur right here or right here. And so if you look on my answer key, you will notice I did the candidates test, but I only used the candidates of -4 and 0, because -1 is going to be a max. And at 1, 4 is going to have to be a max of some sort, or it's definitely not, you know. And then 1 is not going to be a min or a max. It's going to be maybe more like an inflection point or something. Okay? So that's what I did there. You're plugging these values back into g of x. I think, did we already have? Okay, so for g of negative 4, realize g of negative 4 is doing the integral from negative 4 to negative 4. What's an integral when your top and bottom boundaries are the same?
0.
0, right? Because the area under the curve from negative 4 to negative 4 is non-existent. So it's 0. And then g of 0, well, we already did this on the other in part A, but this would be going from negative 4 to 0. What is the area under the curve from negative 4 to 0? And that was, the triangle was 9/2. A is defined to be negative 3. Right? So I had the triangle there is 9/2. A is defined to be negative 3. So then you've got, what, 4.5 minus 3. So you have 1.5. We're looking for an absolute minimum, yes? So my absolute minimum is going to happen at my lowest y value. Okay? If you checked all these other values, none of them should be below 0. Okay? Let me get negative 4 would be 0. The integral from negative 4 to negative 1 would be 9/2. At 0, we just had 3/2. To go to negative 4, when you go 1 over, you're going to be adding 5 to this. So that's going to be 1.5 plus 5, 6.5. You know what, let's just... And when we go all the way over to 4, g of 4 you would have already found on part A to be 11. So if you did it that way, you would still get that that is the smallest one. Which means, did you have to do this, the sign chart? You did not have to. But then if you don't do the sign chart, you have to do all of them here. Okay? Maybe? Yes, no? I knew you were going to want that.
So with calc being in the morning, after we're done, it's just a normal school day?
Yeah, cum laude.
Oh, shoot.
It is a normal school day starting in 5th hour,
Yeah.
or it's cum laude.
I completely forgot.
Most of you it's probably cum laude. I don't know.
So we don't have.
Yeah. I don't understand.
Yeah, so you guys will be free, because normally when the AP ends, you guys are free to go to lunch.
Yes.
And usually it's, with AP Calc, it's C lunch before. It's not like AP Environmental where you guys got released during B. Usually with Calc, it takes all the way up to C. Okay, or just thereabouts. So normally you would eat C lunch and then go to 5th hour. So I don't know, I haven't paid attention to who's going and who's not, but, so if you're here, you're going to 5th hour. Otherwise, you're going to Madi. Yeah, you're pretty much going to be arriving right with the people being honored.
Yeah.
So, because when you mentioned you meeting them at Jim Dandy, I'm thinking,
Exactly.
there's not going to be time. What's he thinking there? Although I guess sea lunch is starting at like noon. But even then, I would think they'd be headed back to the Mountain Center before then, or around, you know. So say the earliest you get to Tipton is 12:15.
Yeah.
I would think they'd be starting to head away from lunch and get back to the Mountain Center if they're not already there. I don't know. What did you guys do last year, servers?
Yeah.
But,
Here we go somewhere.
We ate McDonald's.
The Mount Center.
We got
CW Mount.
done easy early last
We
year.
were, so we just kind of hung
So
around.
just kind of.
oh, that's not mine too. And they're pretty durable for a basic drop off the desk.
I don't know. We can ask Megan about that one.
Oh my gosh, this is so hard.
Uh-oh. What'd you do?
It was a while ago.
I think she broke his calculator.
2 years ago.
Yeah.
Was it the graphing calculator?
Yeah, this one here, that's why it's got, so this was me trying to fix it. What happened is she's like, oh, oops, and it fell and the
Yeah,
screen popped out.
I dropped mine a lot of times on the floor, and yeah, I will say my pink one does have a crack from dropping it on a cement floor at a basketball gym.
That's it.
That was a few years ago, because that was, what's sign guy now?
Future scientist.
Yeah, that was a gym before. What was it called?
The cave.
The Cage, yeah, it was a basketball gym.
Well, that's what-
And so that was the Cage, and I was there one night when Logan had practice, and I'm sitting in the bleachers doing calculus, and I dropped it on the cement floor under me, so. But
Yes.
I thought we were going
I thought we
over
were
the rest of the
reviewing
other tests.
No.
Mr.
So
King.
then
He told us about
They asked us to.
I thought you said we were doing it Monday, but there's not gonna be anyone in there.
Mr.
Maybe
We're
like,
doing it Monday.
maybe like Mike
So-
and, I don't know, is Mike,
they gave
who's
us.
helping with the
velocity,
juniors?
yes.
What?
Who's
This
helping
is
with
velocity
loading with the
information.
juniors?
Velocity information. Okay.
Mike said.
When they start asking about
I think
acceleration,
Mike will be the only one in there.
acceleration
Mike
is
and Hannah.
I'll
the
be
derivative
there.
of velocity. So
Okay.
acceleration
Okay, you
is
go.
the rate of change
The
of
rest of
velocity,
us are gonna go
or it's the slope of
Sit
velocity.
I'll have.
sit
So
and
this is
listen.
the average value.
Do we know who's talking?
And so here,
Well,
we
yeah,
define that
Is
the
it
is
just
different
full?
on the other page. So we
I'm sure
can
Drake
take
will say something,
Sure.
I'm sure
Then the
Locke will
average
say
value.
something, but all of you
because
guys
we're trying to take derivative here. And the thing is, with random
Last year we
functions,
heard what
always have a
Drake
part.
said long.
I don't have a function that I do instantaneously.
The same.
I can only do average rate of change. And so then, we did average rate of change. And so then mean value theorem says that on this interval 0 to 4, since because it's continuous, we can use mean value theorem, then I'm trying to think,
Could you put
what's
that
the
in
wording
my
of the, I can't think of the wording of the actual, thing there, but what?
Because
Uh,
Sophie and Maddie are gone,
Oh, yeah.
so I talked to Sophie,
I know Maddie's
she
like,
wasn't done.
Maddie's like, I'm gonna get it done, and I texted Sophie, I was like, turn it.
what place where is it in here?
Maddie
Yeah.
doesn't talk right.
The one where we talked about mean value theorem, but if the function is continuous.
I was getting
and
a little
it exists, then there's at
hurt
least
by
one
her.
number
She
at that
copied and
value.
pasted all my physics lab.
Okay,
She
there's at
came
least
home,
one number
or
such
came to
that
my
x
house
equals that
yesterday
value.
after the softball game. We
Um,
practiced our posters
so
and she was
some
like,
unknown
"Okay,
value,
just
we
need
don't know,
Ohio."
so some time in
Dude,
there,
It took me like
such
2
that
hours,
it's going to
3
equal
hours.
to
And she just wants me to say things for her.
Where you,
okay?
But
This
it's
just
some of
says,
your own.
where you?
is there a time?
Just get on the bus. So if you have
Okay, it's not
your-
asking
that way
at
you
what
know that you're
time,
with us
but
and all that.
Because we can do this,
And
and
even
we've
with,
got
like,
2.5
your
and continuous, we can say, okay, there is some time there when this will exist. But, and mean value theorem is what guarantees that.
And if you didn't get 2.5 there.
Well, good thing you were correct, not sure.
He was
Correct.
the special.
I think.
I mean, I'd be able to get
Now,
that.
to be honest,
Oh.
you're probably gonna get 2.5, because they're looking for use of mean value theorem, that just, yeah. Yep. Maddie, if you happen to listen to this, hopefully they told you donuts Monday morning, come early.